Hi guys, welcome to 13.3 Angles and Polygons. The frame of the tambourine shown is a regular heptagon. 1, 2, 3, 4, 5, 6, 7 sides. What is the measure of each angle of the heptagon? So angle 1, 2, 3, 4, 5, 6, 7. You will find the answer in example 2. An interior angle of a polygon is an angle inside the polygon. So each of these angles lie inside the polygon, so they're considered internal angles. In the activity on the page before, you use triangles to find the sum of the measure of internal angles of a convex polygon. Don't worry about that. You can find the measure of an interior angle of a regular polygon by dividing the sum of the measures of the interior angle by the number of its sides. So they give us a formula, and it's important to probably memorize the formula or write it in bold at the top of your notes, but they're actually going to give us two. So the measures of interior angles of a convex polygon. So how do you find the single measurement of each internal angle? The sum of the measures of the interior angles of a convex n-gon. They use the term n to represent any kind of polygon. So it could be a heptagon, a hexagon, an octagon. So 7 sides, 8 sides, 6 sides, doesn't matter. Is given by the formula n minus 2 times 180, where n represents the number of sides. So number of sides minus 2 times 180 will be the sum of every single angle on the inside of the heptagon. The second formula, n minus 2 divided by n times 180 is going to be the individual measurement of each angle. So top one is the total of all the angles. Second formula is the individual angles themselves. So example 1, find the sum of the measures of the internal angles of each polygon. A. Well, step 1 is we need to know how many sides we're dealing with. So for A, we have 1, 2, 3, 4, 5. So we have a 5-sided figure. N equals 5. And they want to find the sum of the measures of the interior angles. So they want to know what all of the measures equal together. So that means we're using the first formula, n minus 2 times 180, 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540 degrees. So if you were to add together angle 1, 2, 3, 4, and 5, you would have a total of 540 degrees. So for B, we have to again count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon, so n equals 8. Plug it back into the first formula. N minus 2 times 180. 8 minus 2 times 180. 6 times 180 is going to equal 1080 degrees. So the sum of each angle in our octagon when added together is going to equal 180 degrees. 1080 degrees. Moving on to example 2. Find the measures of the interior angle. Find the measure of an interior angle inside the frame of the tambourine on the previous page. So now they don't want to know what the total amount or the sum of all the angles combined. They just want to know what is the measure of one of the angles in our tambourine. Well, if we go back to the previous page, we realized again it was a heptagon, which meant that it was a 7-sided figure. So example number 2. We saw that it was a 7-sided figure, so n equals 7. And we're using the second formula, which is going to tell us the measure of each specific angle. So n minus 2, 7 minus 2, all being divided by whatever 7 is. Or not what 7 is, whatever n is, which is 7. times 180. So we have 7 minus 2, which is going to be 5. So 5 times 180 divided by 7. And when you do the math, you'll get 128.6 degrees. So the internal measurement of each individual angle of this tambourine is 128.6 degrees. If we hadn't divided by 7, we would have had the sum of every degree, but because we wanted to know what one angle is, we divided it by 7. That has everything to do with interior angles. Now we're going to look at exterior angles. If you extend the sides of a polygon, so if you kind of think about this as the top of our stop sign or our walking sign, if you extend it up or extend it over, when you extend the side of a polygon, the angle that is adjacent to the interior angle is the exterior. So here is our interior angle, the one on the outside is the exterior. Here was our original angle, but by extending that line, we have our new exterior angle. In the diagram, 1 and 2 are exterior angles, and an interior angle and an exterior angle at the same vertex form a straight line. So 1 and then this unmarked one right here lie on the same straight line, so they together equal 180. 2 and then this unmarked angle right here fall on the same line, so combined they equal 180. Let's look at example 3. Oh boy, I don't know how I'm going to draw that. Line 1, 2, 3, 4, and then 5. All right, not too bad. I did okay. We have angle 1, 2, 3, 4, and 5. Notice these are all exterior angles. And then we're told this angle right here is 87 degrees. This one is 134 degrees, 124 degrees, 89 degrees, and then 106 degrees. And again, angle 1 is the exterior angle of 87. So angle 1 and 87, because they lie on a straight line. Angle 2 is the exterior angle and adjacent to angle 134 because they lie on a straight line. Same thing with angle 3 and 124. They lie on this straight line right here, making them adjacent. So 124 and angle 3 are adjacent, 89 and 4, and then 5 and 106 are all adjacent. And now it says, find the measure of angle 1. So angle 1 equals what? Well, if again, angle 1 lies on the same straight line as 87, that means they sum to 180, because anything on a straight line equals 180. So angle 1 plus 87 has to equal 180. So angle 1 plus 87 degrees must equal 180. Subtract 87 to both sides. Whoop. Angle 1 has to equal 93 degrees. If angle 1 equals 93 degrees right here, we can always double check it because these two angles have to equal 180 because they lie on a straight line. 93 plus 87 equals 180, so that has to be true. Let's look at the checkpoints together to make sure we really understand this topic. We're told to find the measure of angle 2. Angle 2 lies on the same straight line as this angle of 134 degrees. So 2 plus 134 has to equal 180. So plus that has to equal 180 degrees. Subtract 34 to both sides. And the measure of angle 2 has to be equal to 46 degrees in order for these two angles to sum to 180, and they have to sum to 180 because they lie on the same straight line. So angle 2 46 degrees. Same thing with 124 and 3. The measurement of angle 3 plus 124 has to equal 180. Subtract 124 from both sides, and the measure of angle 3 has to equal 56 degrees in order for both of these to sum together to be 180, to just prove that they lie on a straight line. And then you just carry that around for each of these. 180 minus 89 has to equal, 4 plus 89 has to equal 180. 5 plus 106 has to equal 180. And then you just kind of figure it out. Fill in your blanks. Moving on to example 4. Bring the book back a little bit. Example 4, teapots. The diagram shows a teapot in the shape of a rectangular hexagon right here. Find the measurement of angle 2. Well, again, our teapot has this hexagonal shape. Boom, boom. This is angle 2, and this is angle 1. To find the measure, so here we don't have the answer for what 1 is. We can't do 180 minus 1 equals 2. We have to use our formula from before because they haven't told us the internal measurement. So solution, the measure of the internal angle of the hexagon has to be n minus 2 times 180 divided by n. That's how we're going to solve for 1. Well, in a hexagon, how many sides do we have? We have 6 sides. And again, this is just drawing back from examples 1 and 2. We have 6 sides, so 6 minus 2 is 4. We're going to multiply it out. We're going to multiply 4 times 180 and divide it by 6, and we're going to get 120. So the internal angle for every single angle on this hexagon is going to be 120. For hexagons, they do not have to sum to anything in particular. So just because this is 120, this can be 120, this can be 120, this is 120, this is 120. They don't have a maximum number. So we used our formula to find the internal angle of our hexagon, and we said our internal angles are 120. Well, that makes it really easy to find number 2 now because they lie on a straight line. So the measure of angle 2 plus 120 have to equal 180 because, again, they lie on a straight line. And if you lie on a straight line, you have to equal 180. Subtract 120 from both sides. The measure of angle 2 equals 60 degrees. All right, I'm going to skip reading this part, and I'm just going to tell you the spark notes of what it says because they say it confusingly. What they're going to tell you in this little diagram is that while your internal angles don't have a maximum value, so these can be really big, what they're going to tell you is that the sum of every exterior angle, so here's an exterior angle, here's an exterior angle, exterior angle, exterior angle, exterior angle, exterior angle. What they're going to tell you is the sum of all of these external angles will always equal 360. So this is what you want to write down. Sum of exterior angles equals 360. And that's just a fact. The sum of every exterior angle is going to bring you back to 360, and that's going to lead you to believe that they're about to make you solve for a missing unknown angle, or an unknown exterior angle. So you have this fun little figure that looks like this. Boom. Boom. Looks a little something like that. And they tell you this angle is 106. This angle is a big X. This angle is 81 degrees. This angle is 100 degrees. And they want to know what is X. You're solving for X. Well, if you know every external angle is equal to 360, or the sum of all external angles, then you just add them together. 106 plus x plus 81 plus 100 is equal to 360. Add them up, you get x plus 287 is equal to 360. Subtract 287 to the other side, x equals 73. So this angle has to be 73 to ensure that all of our external angles sum to 360. And that's all. You can start your homework.